Python Pandas is easiest to learn through a real project. So today we're analyzing tech giants like Amazon, Tesla, and Meta from a CSV file. We will clean the data, pull quick insights, and export a clean Excel report. So let's start. The CSV file looks like this. It is separated with OR operator, not a standard comma, and has three columns. One is company, second one is founders, and then year found. Founders are separated with semicolon. If you want to follow along this video, I suggest you visit my GitHub in the link below where you can find this whole CSV file there. Now that we know how our CSV file looks like, we can start using pandas to analyze the data. So I will import pandas, and some convention is to put it alias pd and use it like that, but you don't have to. Also, pandas store this as some data frame object. And that's why usually you will call your variable that stores your data as df, which is short for data frame. And then here you can write pd.read CSV. You can also read other files, for example, Excel file, but in our case, we'll read CSV file. And here you need to pass the name. In my case, it's called techcompanies.usa.csv. And then if your separation is standard comma, you don't have to pass it as a parameter here, but since mine is OR operator, I need to pass it. You can also give it some encoding, but I want to this time. And let's see if we actually loaded the data correctly. For that, I will print here head, which is actually a head function that prints first couple of rows. By default, it prints first 5 rows, but here you can pass as many as you want, like 3 or 2 or whatever. But I will leave it at default. Another useful quick function for scanning your data is, for example, info function, which prints some general info about your data. You will see what that info looks like when you run the code. And also, you can run and scan for missing data. To do that, you need to call isNA function, which checks if something is none or null, or if it is empty string, whatever, however you want to call it. If it's none, then this returns 1. If it's not none, it returns 0. And if you write here sum, what this will do is, for every column, it will give you the number of missing data. Let's run the code so you can see that how it actually works. As you can see, head, it prints first 5 rows, and also it puts these 3 dots so it doesn't look bulky. For info, you have some general info about your data. For example, it says here I have 33 rows. I have columns company, founder, and year found. I have 36 non-null objects for all 3 columns, and first 2 columns objects are object, and the third one is actually an integer. Also, it says how many memory it uses, and some stuff like that. And as you can see here, missing data, it says that company has 0 missing data, founders, year found, also 0 missing data. And we know that from this here as well, but you can check it manually like this. Next step after you loaded your data is to clean your data, because everybody has some different typing style. They put some more spaces that they don't need to, or somebody doesn't even put any spaces. So you want to remove them and also fix if some data is not put correctly. For that, I'll write data frame, and as I have said, data frame is similar to dictionary, so you will see a lot of these square brackets and here some column names which will actually resemble a dictionary. So here you can write, for example, let's put company here and remove all the spaces of companies if somebody put extra on them. So I'll write here company, but before I do that, I first need to convert this into a string object. As you have seen, this company object is actually object. So I'll write as type and here put how I want to use it. I want to use it as a string. And if it's a string, we know that I have strip function. But now before this strip function, I have to write string to know that is a string strip function. I will repeat this code for founders as well. And because year found is a different data type from founders and company, I want to process it, clean it a little bit different. For example, if somebody put a decimal integer or something that doesn't really make any sense to be a year, I want to put none there or null. So I'll write data frame and here year founded And how I will do it, I will try and convert it into a numeric. So I'll write pandas dot to numeric, and what I want to convert, which column. In my case, it is year founded. But what happens when error occurs? In that case, I have several options, and in mine, I will put coerce, which means if error occurs, put none. And next, I want to remove all those none values. I mean, all those rows that have none values as year found. So I will write data frame to be data frame, data frame of drop NA, which means drop nothing or none, whatever. And where to look for the none values, you give it a subset, a list of columns. In my case, it is only year founded. And you want to copy that and put it in my data frame. And now everything is fixed. The only thing left is to tell Python explicitly to look at this year found as an integer. So the same as before, I'll write year founded to be data frame of year founded and interpret it as an integer. And officially, I've cleaned my data. After you've cleaned your data, you usually want to process it or even update it somehow. For example, maybe I want to sort my companies from the newest found. So here I will write newest, but in most of the cases you will have a lot of columns, rows, and you don't want your Python to print all of them. It will be a mess and you won't see anything. That's why we will usually use head to print first 5, 10, or whatever. That's why here I will write newest underscore 10 to know that I will get only first 10. So I can write data frame dot sort values, and then here based on what column. And I want to sort it in year founded column. And next, a parameter is very important. It's called ascending, which tells you how you actually sort your data. If you pass nothing here, it's by default true, which means it will grow. But if you write here false, it means it will decline. And I want only first 10, so I'll write here head and pass 10. And let's print this first 10. So here I'll write underscore n newest 10. And here print newest 10, open the braces here, and you write the list of all the columns that you want to print. And in my case, I only want to print the company name and the year it was founded. I don't need anything else. Let's run the code to see if everything is correct. And as you can see here, it sorts companies from the newest found to the last found. And these are the top 10, which means OpenAI is the first found. These indexes here may confuse you, but Python keeps the original index of your row. If you don't want that, you can simply write here dot reset underscore index and say drop equals true. And now it will create a new set of indexes that start from 0. Let's run the code. And as you can see, new set of indexes is created, starting from 0 until 9. But now you maybe want to sort only the companies that are found from the 2000s above. And to filter that, you can write founded. I'll write 2000 plus to be the name. And it should be data frame of, and here you pass data frame. Then based on what column you want to filter it, in my case, it's year founded. And what you want to check is if it's greater or equal to 2000. If that is the case, then you want to sort the values based on year founded. And this will sort your companies that are found from 2000 above. But because I didn't say ascending to be false, by default it's true, so the values will actually grow. It will be completely different from the newest 10. And let's print that. Print founded 2000 and plus. And I can print that found 2000 plus. And what I want to print is actually, I want just to print the company name. So I need the company here and the year founded, nothing else. And of course, I don't want to print all of them. I'll write just head, and in this case, let's be 5. Let's run the code to see if everything is correct. And of course, I have some misspelling here. Here, founded. Now I think everything should be okay. Yeah, everything is okay now. And as before, Python keeps the original index of your row, and that's why here I have 21, but here I have 1. If you want to fix that, you know how to. You're free to do it. And in this case, we have a growing set of numbers here. This is all good, but what if I want to add some colon? How can I do that? As I said before, data frames are like dictionaries, and how you create new keys in your dictionaries, you simply put the name of your dictionary, open the square bracket, and write the new key value. That's exactly the same here. Let's find the number of founders of a certain company. And I will name this row, column, founder count. And this one is going to be actually a little bit more challenging than the rest because I need multiple processing here. So I'll write here parentheses and write what column should I use for comparison or to process my data. It is, of course, founders because I want to find how many founders a company has. We already know that these founders is now a string type, so I can freely use string manipulation. And I know that all the founders are separated with semicolon. So I can call a split function and get the list of founders. I'll write here string dot split and pass what should be the split character. In my case, it is semicolon. And you're probably wondering why can't I just write len and then pass the list? And you can't do that because maybe you have some extra spaces and you have a list that has empty string or space characters as elements. That is why we will use apply, which actually helps you apply a certain function that you created or from another module. In my case, because this is going to be very simple and I don't want to use that function anywhere else but inside here, I will use, of course, lambda function that will have one parameter list and it should sum every element. How you do that? It adds 1 and check for I in list if that string dot I, we convert that I into a string. I think it's already string, but this is for safe purposes. And check strip, after we strip spaces, is it empty string? If it's empty string, if it's not empty string, then I want to add. If it's empty string, I don't want to add. That's why I only have one if and no else. And this is it. This should work. Now let's print all those founders to see. I'll print, call it here, founder count. And what I want to print is data frame and what columns I want company and only the founder count column. And for how many, let's say first 10 companies. Let's run the code to see what happens. As you can see, we have a company name and the founder count. It says Amazon has one founder, and we know it's Jeff Bezos. Here, Meta has 4 founders, which I actually didn't know. Here, Tesla has 5, Apple 3, and etc. Well, this is all very useful if we want to keep that data in our Python code. But most of the time, when we work on something, we actually want to export it in a document file or an Excel file. In this case, I want to convert this data into an Excel file. To do that, it's actually very simple with Python. You can simply write here out file and here name your Excel file. For example, mine will be tech companies minimal XLSX. This is actually Excel extension. You need to write this so Python knows that this is actually an Excel file. And because I want to work with files, of course, I will use Context Manager. And I'll write with and then use pd.excelwriter. And here you write, of course, the name of your file. And after that, you write the engine which will operate all those operations like creating a new sheet or adding rows, removing rows, whatever. And in my case, engine will be open by Excel. And I will store this as writer. And now we can start. To add your data in a Python file, you need to write the name of your data frame, and then to Excel. Then here you need to use that engine or the variable that is actually going to write and perform all those writings, I mean, and that is in our case writer. Next parameter is, for example, sheet name. You don't have to provide it if you want all of them to be on the same sheet, but if you want to spread them like I will, you need to provide a sheet name. In my case, let's be all clean. And also, as you can see, Python stores indexes and you can put them, but you don't have to because Excel already has indexes on the left. Most of the time, you'll write this index to be false. And that's it. We can repeat this as many times as we want and as many sheets we want. For example, I'll create 2 more sheets for the founders of 2000 plus and this newest 10. And here is the code for both of them. It's completely the same. And let's here print just done to see if something went wrong. If here we have some error and this is not printed. So let's run. Of course, I have a misspelling engine. Let's run this. And as you can see, done is printed, which means no error occurred and everything should be fine in our Excel file. So let's open our Excel file. My Excel file is here. It will be in the same folder your project is. And as you can see, here we have all those data stored. The company, the founders, and the year found, and also that new column that we created, founder count. And it has 36 companies. And we have also 2 new sheets that we didn't have before. And this one stored all the companies that are found from 2000 plus and sorted them in ascending order. As you can see, the numbers grow. But in the newest 10, it sorts them in a descending order and only the newest ones, the first 10 newest ones. If CSV files confuse you, watch my previous video on working with CSV files in Python. There, I explain reading, writing, and handling delimiter properly. It will make everything in this Pandas project even easier. Don't forget to subscribe for more coding tutorials.